All right, hello guys. We're gonna learn how to use our calculators today in order to find the intersection points between two graphs. And it's a really beneficial thing to know, especially like on bigger tests like the ACT or the SAT. You'll definitely want a graphing calculator just to make your life easier and to speed up the process of answering some pretty tough questions. So I don't know if this page is actually in your binder or not. As I was looking through my materials, it may be an older file that I printed out for this semester, and so I'll have it available for you guys to just put into your binder kind of after the Systems 1 section. And so yesterday we talked about graphs and tables. This is going to deal a little bit more with equations. And so if you have a Casio calculator, the steps are actually on the back of this page, so that's something that you can look for. But most people will probably have one of my Texas Instruments, the TI calculators, or usually that's one of the more popular options. And so hopefully your page looks just like this. And we're going to do a couple of examples here at the bottom, and then you'll have some practice to do on Desmos to see if you're understanding the steps and able to navigate some of the pitfalls. So with question number 10, notice it's blank here on this page. I just kind of want to make up a problem, and you can always practice and make up your own problems as well. But we have two lines for a couple of different functions or shapes. And the first one that I'm going to do here, hopefully you can read it, is y equals x squared plus 5x. And then we're going to finish with a constant of 7. So plus 7 at the end. We'll figure out how to type that into a calculator in a minute. But then the bottom one, I want it to just say y equals x plus 7. And so those are going to be two different shapes, a line and a quadratic. And so how do we put those into a calculator? Okay, if you look kind of at the steps here and read along, we got to turn our calculator on. That's the first thing. So hit the on button. And if you have stuff that's on your screen, I would encourage you just to clear it out so it's blank. But once you have kind of a blank slate to start with, we're going to be in the y equals menu. So click here on the y equals button. If you have things that are already typed in, I would go up and down, and I would just clear them out. So if you had 25 x or anything like that, so I would just get rid of anything that's already here. So you can just go up and down and press clear, and it should be blank, similar to the home screen was blank. And we're going to go ahead and we're going to type in the two equations that I wrote in purple up here on line 1 and line 2. Okay, if you kind of scroll up and down, you can see that we have space for 10 different equations, and that's a lot, but we'll typically just use a couple at a time. So in order to get the x, notice right next to the alpha we have x. There's also t and theta and n, and those are for some of the different modes that your calculator can do. But if we press it, x should show up. If it's one of these other letters, you'll have to go to mode and make sure you're set on our normal mode, or the function mode, I think, is the one that we really want selected. So back here, once we have x, getting a squared is pretty easy. There's a button for that. And then we'll go ahead and we'll say plus. Whoa! My x got written over. Sometimes your calculator will do that. So x squared, and then we'll have plus 5x, and then plus 7. Okay, and you can press enter, or you can press the down arrow. That's going to bump us into the next location where we can do x, and then plus 7. Now after we have it typed in, we obviously want to look at the graph, and so that's the second step here on your paper, is to hit the graph button. That's over in the top right. Okay, so you press the top left to enter them in, and now you press the top right to see what you entered. And the picture here is pretty cool. It did it a lot faster. We didn't have to know about maybe some of the patterns that go with quadratics or how to graph a line. It just does it for us. And we can see, just from the picture, it looks like these things cross twice, but we don't know exactly where. And so let me tell you how to figure out those points. You're going to press second and then trace. The little yellow word, anything that's yellow, you have to press the second button. The little yellow word up here is calc. We're going to calculate where they intersect. So go ahead and press second and trace. And these are all the different things we can calculate. We can calculate values, so where is its position on the graph. We can calculate the zeros. which hopefully you remember from the past chapter, that just means the x-intercepts. We can calculate minimums and maximums, so lowest points on the graph or highest points on the graph. That was from the first chapter. But the one that we're most interested in is where they intersect and where they cross each other. So we'll go down to the fifth option, and we'll just press Enter. Okay? One of the first things you're going to have to do if you press left and right on your arrow pad is you have to figure out which shape you're on. Okay? And so it looks like my little blinker is here on the curve, the U quadratic curve. And all you have to do to find the intersection points is drag that little cursor and direct it to be close to where they intersect. You don't even have to be that close, to be honest. So I'm hanging out over here on the left side, and your calculator in a minute will look over in this left area close to your cursor. So your calculator's a little needy. It's going to ask you if you want to select the first curve available and then a second curve available and then guess. So typically, what I have kids do, once you get close to where they intersect, you're going to press Enter 3 times. The first time is to select the first curve. Then it jumps to the other shape that you have. It's asking you, is this the second curve? You want to hit Enter a second time. And then, as I said, it's kind of needy, and it wants to know if it should guess. And that's the whole point of why we're using a calculator. So hit Enter a third time. It'll think for a second, and then it's going to spit out an x and a y value down here at the bottom. It says the intersection point is at -4, 3. So left 4 up 3 is that pixel, that dot. So on your paper, it'd be nice if we could get kind of a sketch of this. We're going to have this intersection in the second quadrant. It looks kind of like they intersect close to the y-axis, so I'll try my best to maybe draw a picture of that. Okay? Now, it doesn't have to be perfect. Sketches are just kind of a loose drawing so you remember what's going on. But try to do your best. Obviously, that's the quadratic that's up there. And we'll go ahead and we'll make our line do something like this. Make sure to put arrows on the ends because those lines and quadratics keep going past the window that we can see. And so that intersection point there in the lower left was at -4, 3. If we go back, those are the x and y values. So what do we do about this other intersection point that seemed to be close to the y-axis? Well, the steps that we went through, going to the Calculate menu, we're going to have to do that again. Now, if you have a Casio, the Casio steps are actually really easy. You get to go back and forth with the arrow pads, and it just tells you all of the answers. But, if you have a TI, and if there were 4 or 5 answers, you're going to have to do this process 4 or 5 times. So notice I'm going closer to where that intersection point will be. I just have to be in the ballpark, roughly over there. I'm going to press Enter for the first curve. It will automatically go to the second curve, and I'll press Enter. And then I'm going to have Enter again for it to guess. So basically, once you get close, you just go Enter, Enter, Enter. Okay, if you see it asking you questions at the bottom, that means you did not press Enter enough. Now, something really interesting happens for this particular problem. You might not even get the same kind of answers down here, but it says -1.8, and then there's the E with a -14. So let me talk about that. -1.8 E, -14 is in scientific notation. That's basically saying -1.8 times 10 to the -14th power. And if you think about what that negative exponent is telling you to do, it says, hey, we got to move the decimal 14 places. And because it's a negative, we're moving it 14 places to the left. So can you imagine? That's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 spaces. All of those spaces are filled in with a 0. And so what number is this really, really close to? Well, this is basically 0.0000000000000000018, and it's on the negative side of things, is basically nothing at all. Okay, so sometimes with the calculator you have to interpret a little bit. It's trying to be a little too smart for its own good. But that's an x value of 0, And as we saw over here on the calculator, the y value turned out pretty clean. It was a y value of 7. 0,7 seems to be right around where that would cross. So occasionally your calculator will try to be a little too nerdy, and you just have to interpret that for it. But a lot of times you do get awful decimals, and so the decimal that it gives you, as long as it's not using crazy scientific notation, it's probably the correct decimal. And so you should just copy down 2 or 3 decimal places, usually is the case. So let's go ahead and let's try another situation. All right, let's go ahead and let's just make something up here. Y equals, let's do a negative this time. We'll do negative x squared plus, 4x, and then plus 1. And we'll keep it small. And then the other function, let's go ahead. We can do quadratics. We can do lines. Let's maybe stick to a line. And negative 2x plus 7. Why not? Okay, so just to go back through those steps, we'll have to go to the y equals menu. Probably just want to clear things out. Okay, if you are running into an issue, let's just try to follow along a second time here and see if we can iron things out. But the Desmos activity that you'll be practicing on actually goes through several of the problems that can happen. Like if you graph it and the picture doesn't look the same, that's okay. The Desmos activity will teach you how to fix that. It really is just an option with your zoom and zooming, so it's standard 10 by 10 by 10 by 10. If you graph it and then an error pops up, sometimes things are turned on, like some of the statistic plots are turned on, and sometimes other people have typed things in, particularly at the bottom, and you can't see them because you're hanging out here in the first and second row of things. And so the Desmos does a really good job of helping teach you how to navigate some of those problems. You just got to watch the short 20-second video to see what you do. So anyway, back to our problem. You got to keep in mind a negative and a minus to a calculator are different, and so the negative button is down in the bottom. It would give us an error if we use the minus button. So we'll put x and squared in here, and plus 4x, and then plus 1. I'll go ahead and press enter. We go down to the second line. We need a negative again, not a minus sign. We need a negative, and I forgot the 2 in front of x, and then plus 7. Okay, so we'll just press enter, and we can graph those. Looks like we have an upside down U. It's been reflected. That makes sense. And then our line is also reflected. It's going down with a negative slope. So these look like they cross twice. Okay, if I draw a sketch, my quadratic should be kind of turning around in the first quadrant, and then we have one intersection point kind of up there, and a second intersection point down in the fourth quadrant. So I'll do my best. That is not my best work, but it'll pass. Just a sketch. And so we're going to try to find that point here, and then this point over there, to the best of our ability. And a calculator will help out a ton. So we need to go to second. Okay, notice second will always give you the up arrow, so you get these upper options. Second, trace. That will calculate where they intersect. So we'll just go down to the fifth option. We got to get close-ish. So my cursor is close to the top intersection point. We'll press enter 3 times. Enter, enter, enter. It thinks for a second, and it's telling us, these intersect at 1.267, comma 4.464. That is a very specific location. This would be pretty hard to guess or estimate. It would be pretty hard to figure that out using algebra, which we'll do next week. So it's really nice that a calculator can speed things up for us. But let's go ahead and let's write those down. I'll put it close to that dot. So 1.267. And I'm not rounding or anything like that. I'm just going to write the first 3 numbers that I see, and then 4.464. The second solution down there in the fourth quadrant. Let's go ahead and let's go through that process. Second, calc, down to intersect. We'll have to scoot over, just close. So you're always going to go over left and right first. I wouldn't really use the up and down buttons. What an up and down button will do, just in case you press it. If you press up or down, it jumps from one curve to the other. And it's really nice because you have colored screens. You can see the colors change. It'll be like red and blue. But I usually just stick to the first thing that pops up, get my cursor close, press enter 3 times. Once you've practiced this enough, it actually is pretty easy. So it looks like it's telling me 4.732 and negative 2.464. Those are the x and y values of that point. And that makes sense. We're going over a little bit and then down into that fourth quadrant. So 4.732, comma, negative 2.464. All right, and that's all it takes. So being able to practice this and use it as a an extra resource of like, what's going on? Can I see a picture? And getting to know some of the powerful features that a calculator can do is the whole point of why we want you guys to have a calculator. Now, while you guys can borrow mine, I would still encourage you guys to maybe try to buy one, just because you will get familiar with your calculator and you get to always use your calculator. My calculators, like once you get out of my class, you might not be able to use them anymore. So just a thought. But go ahead, take 15 to 20 minutes to work on the Desmos practice. If you are pretty speedy with this, it probably will not take the full 15 or 20 minutes. And then after you're done with the Desmos activity, I'd like you to work on your homework. That first homework, it's going to be due next week, but you can probably get it finished up today and turn it into my bin, and I'd appreciate that. So hopefully you guys found this video helpful, and hopefully the practice is helpful as well. Watch those little videos if you are getting errors. Very important to figure out how to deal with those. And I'll be back next week, and I hope to see you guys then. Take care, everybody.